Hi everyone, welcome to Big Direction. We believe on reshaping the tradition of learning. Let us start with class 10, chapter number 9, carbon and its compound, lecture number 3. So, in the previous lecture, we discussed all about saturated carbon, how their structure will be, and how to name that saturated carbon group. And I had given you one table too. So you have to remember the table and you have to remember all the saturated carbon name with the number of carbon. Now today we are going to discuss the type of unsaturated carbon and how the structure of the unsaturated carbon have and how you are going to name them. So let us first understand the remaining saturated carbon group. I mean to say the next, we already discussed the straight chain. Now there are two more, branched, branch chain, saturated carbon, and cyclic, or you can say that closed chain. So let us first discuss this two and then we'll go for the unsaturated one. Now the branch chain, it's mean that what your one carbon is branched with the straight carbon structure. So suppose I'm taking three carbon group. Now this they have three carbon. It's mean that the name of this group is propane. If I'm writing three carbon, now you know every valence electron have hydrogen. So this end of this two carbon have three hydrogen like this, and the mid one have two because if you see the middle carbon, two valencies are already occupied. Now here I want to make it branched. So what I will do, I will attach one more carbon in the place of this hydrogen because I want to branch. I am choosing the second middle one. You can choose any one of them, but I am choosing the middle one. So in the middle carbon, I'm going to branch one more carbon, and if you see that now this carbon have only one hydrogen to attach because other three are already occupied by the carbon. Now, if you think about this carbon, then this carbon have three valencies remaining. So all three valencies are occupied by the hydrogen. So like that, the branch chain will be continued. And if you write the name, then if you count the carbon name here, then carbon number here, then you have 1, 2, 3, 4. So it's mean that you have 4 carbon. So it is, if you have 4 carbon, then the number of this group is butane, and that's why it is known as isobutane. Now, why it is iso? Because if you see that iso means if your carbon is attached, if your branched carbon, whatever the carbon is branched, if it is attached to the second number of carbon, second is the least carbon number, then if it is attached with the second number, least carbon number of the chain, then it is known as isobutane. Now, if I take the, if now here I had chosen only three carbon group, now let us understand with the four carbon group. So if I will write butane here, then this will be my structure. Now every valency will going to attach with the hydrogen like this. I am attaching the hydrogen. Now this will be my butane. Okay. Now if I want to make it branched, then what I will do, I will remove one H. Again, I am choosing the second one. So here I will write one more C for the branched. This will be my branched C, and this C have three valency. Now here, if you see, if you number this chain from the right to from the left to right, then it will be 1 2 3 4. So here also you have the branched carbon on the second carbon. So that's why it is, now you can count 1 2 3 4 5. So it is your isopentane. So like that, the branch chain of saturated carbon will be proceed. And you can see that every carbon are attached with the single bond. Now, the closed chain or the cyclic chain reactions are somewhere somewhat like, just wait, I will write properly. Overwriting is happening. Just wait. Closed chain or the cyclic chain. So we already have the introduction part of closed chain. So let us go with the triangle. So this is my closed chain, the first triangle. Now if you see that here, there are three carbon attached in the cyclic form. Now if you see, this carbon have two valencies remaining. So this two valencies are occupied by the hydrogen. Here also we have two valencies occupied by hydrogen. Here also, so all are occupied by the hydrogen. Now, if you see that there are three carbon. Now, three carbon group is, you know, it is propane. So now here it is in the cyclic form. That's why you can write it as cycle. It is not cyclic. So you can write it as, here you have three carbon. That's why you can write it as cyclopropane. Similarly, if you will write this cycle with the help of four carbon, then again every carbon have two hydrogen valencies. Valencies are occupied by the two hydrogen like this. Then here the name will be cyclo 4 carbon. That's why the name will be cyclobutane. And so on it's proceed. So as you can see that the name of the compound is depend on the number of carbon. And this is all about the saturated one. So how many numbers are present in the compound, you can name it then. If there are two carbon, then you can write it as ethane. If there are three, you can write it as propane, and so on. And I hope you remember that all seven hydrocarbon name. It is nothing but methane, ethane, propane, butane, pentane, hexane, heptane, and other three also. Octane, nantane, and the decane. So in your syllabus, only seven is enough. So that's why I had given you only seven. So please do remember that thing. Now let us understand the other unsaturated carbon structure. So I will erase this all, or else I will use this slide. Okay. So the unsaturated carbon is basically divided into, you know, unsaturated carbons are divided into two parts: double bond and triple bond. A double bond is known as alkene group, AENE. Triple bond is known as alkyne group, YNE. So let us proceed with double bond first. Now, what does it mean? Double bond means what? It means that your two carbon have double bond. So for sure, it is not possible with methane, because methane have only one carbon. So you cannot make it double bond. Hydrogen are attached with the single bond, but you cannot make hydrogen with the double bond, because your hydrogen have only one electron valence, so you cannot make it double bond in between carbon and hydrogen. That's why methane is not possible in the double bond in the alkane group. So that's why we are going to proceed with two carbon, and it is nothing but ethane. Now the normal ethane structure is C C and the remaining valencies are occupied by the hydrogen. This is your normal ethane structure. Now, if I want to make double bond, then I cannot make it with the hydrogen. It is a bad option because hydrogen have only one electron, valence electron. So that's why we are going to choose carbon. Okay, carbon have four now. So what we can make, we can remove one hydrogen from both the carbon, and we can make it as double bond in between two carbon. Okay, so here I remove two hydrogens, like one hydrogen from this carbon, one hydrogen from this carbon. Now this carbon also have one valency and this carbon also have one valency remaining. So what I did, I converted into the double bond. Okay, so now you can see that the carbon valencies are occupied fully. 1, 2, 3, 4. Here also 1, 2, 3, 4. But now I had written this reaction in the form of double bond. Now this group is come in the alkene. So that's why your name also changed. Now it is not your alkane. Now it have double bond. That's why it is known as ethene. Similarly, if you try with the third three carbon, then it is propane, and propane structure is C C C. Now, if you see that if there are three carbon, then you have two choices to make double bond. Either you can make it in between first and second, or you can make it second and third. So let us choose the second and third one. I will choose second and third one. So what I will do, I will make double bond here, and the remaining valencies are occupied by the hydrogen. Now this one have three, so I will write three hydrogen here. Now if you check here, then 1, 2, 3, three are already occupied. So only one valencies of hydrogen is remain. So that's why I will attach only one hydrogen here. And then if you check this one, then two valencies are occupied with the double bond. So the remaining two will be occupied by the hydrogen. Now, again, it is not your propane because it consider double bond. That's why the name also changed. So now you can write it as propene. Now the fourth one, if I will take four carbon. Now, again, if you see, you have more choices. When you take three carbon, you have two choices. Now if you have four carbon, then you have three choices. Either you can make it in between second and third, or you can make it third or fourth and one or two. So it's like that. When the number of carbon is increases, the choices of to write double bond, the choices of to introduce double bond will also increase. So that's why here also you have three choices to make double bond. So what I will choose the last one. So I am writing double bond here. So the remaining valencies are occupied by the hydrogen. So you can see that. Now here you have 1, 2, 3. Three valencies occupied, that's why you have one. And here you have already two valencies are occupied, that's why you will attach only two hydrogen here. Now again, this the name also change, so that's why it is butene. Now you can make it double bond anywhere you want. It's not necessary you can make it only the last two carbon. You can make it anywhere. The name will be this butene. So on it will proceed. Now in this, now that further you just try fifth, sixth and seventh. Now let us understand the second type in the alkene is iso group. So as I said, iso means you have to attach the branch carbon into the least number of carbon in the chain. So let us take the example of pentane. Right now, what I will do, I will branched my carbon here with the double bond because I'm discussing alkene now. That's why I will introduce double bond here. So I introduce double bond with the branched carbon. Now just write down the hydrogen, whatever the valencies are there. So here you have three, here you have three, and the remaining one have two. Now if you check here, then one, two, three, four. This carbon have no valencies for the hydrogen. So that's why let us go for with this. So here you have two valencies. So this attached hydrogen. How to name this group? How to name this compound? So as I said, it is iso. We take it one, two, three, four, five. Then it is attached with the second carbon in the chain. So that's why how you will write? You will write iso 1, 2, 3, 4, 5, 6 isohexene because you have double bond. That's why isohexene. And one more thing for the numbering part, what you can do that uh, for writing the proper name, what we can do that like in what sequence you have number of carbon chain, from that you can start the numbering. Suppose if you check here, this this one is branched, okay? So we can start from here also. 1, 2, 3, 4, 5, and this one will be 6. Or or else, okay, don't do this. We will discuss this thing in the while writing IUPAC. Okay, so not we will not discuss here. Okay, so like that you have to write isohexene, isopentene, and isopropene. Do remember iso means the branch carbon will be attached to the least carbon present in the chain. So least carbon is nothing but the second one. So that's why always the iso group is attached with the second. So this is all about iso and the branched alkene, branch structure of alkene. Now let us discuss the cyclic. Now here you have, suppose I want to write cyclohexene. Then how I will write? So first of all, I have to write the hexene structure. So hexene mean that six carbons. So six carbons will be attached like this. Now what I will do? You can write double bond anywhere you want. Now I am introducing a double bond somewhere here. Now other are basically have single bond. Now if you check, the carbon have two valencies remaining. So all two valencies are occupied by the hydrogen. Like this. Now here you have only one hydrogen. Here also you have only one hydrogen. Now this will be the cyclohexene structure. So this is all about alkene. Now please try the reaction of remaining hydrocarbons for the alkene. Take it as homework. Now the next group is nothing but your triple bond and which is known as alkyne. So let us proceed with alkyne. Triple bond named as alkyne. Now, as I said, this group have triple bond. Again, methane is not possible because methane have only one carbon. You cannot make a triple bond with the one carbon. So that's why methane is not possible in the triple bond too. So again, we are going to proceed with ethane. Now, ethane have two carbon, so we can make it triple bond here because carbon have four valencies, so we can make use of three valencies. Another one will be occupied by the hydrogen. So what I will do, I will make triple bond in between two carbon, and the remaining valencies are occupied by the hydrogen. Now this will not ethane because we introduced triple bond here. That's why the name of this compound will be ethyne. You have to change only the last three alphabet. Similarly, if you go with the 3 carbon, again you have two choices. You can make triple bond in between 1 and 2, or you can make triple bond in between 2 and 3. So again I'm choosing the last two carbon. So here I had choose last 3 carbon, and this will be my triple bond. Now here you can see that only one valencies are remaining, so that's why I can write only one H. Here there will be no valency, that's why no need to write any H. Here you have 3 valency for the hydrogen. Now if you have 3 carbon, then the name will be propine, because I had introduced triple bond. Likewise, other hydrocarbons also we can write by introducing triple bond in it. And do remember, if the number of carbon will increase, then you have more choices to introduce triple bond in it. So please, this one also take it as homework, and please try with other hydrocarbon too: butane, pentane, hexane, heptane. So today you have two homework. You have to write alkene structure, and you have to write alkyne with the other hydrocarbon which was remain. Now let us understand the new concept. Oh, before that you have one question. Which of the following are saturated hydrocarbon? These are the four options. You can see that. You have to find it out which one is saturated. First, let us eliminate the unsaturated one. So triple bond and the double bond is unsaturated. So you can eliminate this two, second and third. Now you have only two choices. Now if you see the third one, then okay, these two carbon are totally uh, balanced. But if you observe this one, then this carbon need one more hydrogen, because the valencies of carbon is 4, and here only two and only 3 valencies are occupied. So the remaining one is not occupied. That's why it is not balanced one. So that's why again this is wrong option. So the right option is the first option. So first one is your saturated hydrocarbon. The first one is totally balanced and you have single bond. That's why the answer will be first. Now let us understand the functional group. Now what do you mean by functional group? What does it mean? Basically, hydrocarbon means, as I said in my previous lecture, that carbon are not ready to pair with other elements in the periodic table, because other elements are very dominating. So that's why carbon decided to make a pair, make a bond with the hydrogen. Now the carbon is not satisfied with the hydrogen. Now these functional groups are basically, they want to be a friend of carbon. They want to make a bond with carbon, and carbon also agree to make a friendship with this functional group also. So there are three functional groups present which want to make, like they want to make friendship with the carbon. So let us first understand the functional group, then we'll discuss how to make a friend, how to make the friendship of the carbon and the functional group, how to add this functional group in the carbon chain. So the first functional group is halogen group, and it have chlorine, bromine, and iodine. So halogen group have, this is your halogen group, and it have chlorine, bromine, and iodine. and this will be the functional formula for the halogen group, and they already come with the bond. Cl for the chlorine, Br for the bromine, and I for the iodine. So whenever uh, you are going to attach with the carbon, then you will use this functional group. You cannot write chlorine, bromine like this. You have to use the functional formula to attach in the carbon chain. Now, if I attach functional group, so I have to change the name also, like that compound name also change. So for that, we make use of prefix and suffix. So this halogen group have prefix. I hope you know what is prefix and suffix. Prefix which come before the word, suffix which come after the word. So halogen are basically come before the word. And prefix for the halogen group is, for chlorine, the prefix is chloro. For bromine, the prefix is bromo. And for iodine, the prefix is ido. So whenever you attach the functional group, chlorine, bromine, and iodine, you have to change the name too. So for that, we will make a use of prefix, which is nothing but chloro, bromo, and iodine. Whenever I discuss you the IUPAC name, then I will explain you this to how to write and how to attach. Before that, let us understand functional group first. Now, the second functional group is oxygen. They also want to become a friend of carbon. So this oxygen group have five groups. So the first is alcohol. Alcohol functional formula is OH, and here you are going to write suffix while naming. So the suffix is OL. So you introduce OL after the parent name. Now aldehyde, the functional formula for aldehyde is C double bond OH, and suffix for the aldehyde is Al. Ketone, C double bond O. And as you can see that all the functional group are coming with the bond. So with this bond, they are going to attach with the carbon. And the suffix with the ketone for the ketone is ONE. The fourth one is carboxylic acid. The functional formula for the carboxylic acid is C double bond OOH, and the suffix for the carboxylic acid is oic acid. And the last is ester. Ester come with the functional formula C double bond OOR. This R contain other hydrocarbon. Do not get confused. What is R? So R is nothing but a other hydrocarbon chain. And the suffix for the ester is O8. Now the next functional group is nitrogen group, and it have two, amino and nitro. The functional formula for amino is NH2, and for the nitro is NO2. Again, they are also come with the prefix. So for the amino, for the amine, the suffix is amine, and for the nitro, the suffix is nitric. So please do remember this table when I will going to discuss the IUPAC name. This table is very important. Before that, you have to remember that hydrocarbon name table too. That 7 hydrocarbon name. So please both do remember this two table for the next lecture. And with this table, you have to remember the functional group and suffix too. Now, I already explained the functional group, so that's why I will not going to explain one more time. I already explained it. So let us proceed further, and let us discuss what is homologous series. So homologous series basically defined as the group of compound having same functional group, similar chemical properties, and successive number differ by CH2 group. Which means that suppose I had taken ethane, methane, CH2, CH4. Now if I want to add here alcohol, if I will add alcohol here, so it will be CH3O. If I will take ethane and if I want to add alcohol, so then it will be C2H5OH. Right? So this all have, if I will, so on it will proceed, propene, pentane, butane. So if I will add OH, so you can say that this all hydrocarbon have same functional group, which is nothing but alcohol. So if they are belong from the same functional group, so their chemical property also same. But what is different? If you can see here, here you have CH3 and here you have C2H5. So the difference of this two group is here one carbon is increased, that's why C, and two hydrogen increase in the second one, that's why 2. So if you write propene C3H8 and if you add alcohol here, then it will be C3H7OH. Again, if you see that only CH2 is differ. If you add CH2, then it will be propene. If you add CH2 further, then it will be butane. So what is homologous series? It means that they have same functional group, and if they have same functional group, it means that the chemical property also same, only differ from the CH2 group. So this is all about today's lecture. I hope you understood. In the next lecture, I'm going to add functional group. I will explain you how to name them and how to write IUPAC name. So for now, bye, take care, and thank you for watching my video.